When dealing with a situation where puck lights installed in a hutch are now concealed in the soffit, presenting both heat and code compliance issues, there are several potential solutions to explore. Firstly, consider replacing the existing puck lights with heat-resistant models. Research and install puck lights specifically designed for concealed enclosed areas. These lights are engineered to minimize heat generation, reducing the risk of overheating and fire hazards. Look for products that are certified for enclosed installations and comply with relevant safety standards. Secondly, investigate hardwiring the puck lights. Remove the existing puck lights and replace them with hardwired puck lights that do not require cords. Hardwiring eliminates the need for cords running along the top of the hutch, simplifying the installation and reducing potential fire hazards. Ensure the hardwired lights are properly connected to the electrical system by a qualified electrician and that all connections are made in accordance with local electrical codes. Thirdly, explore the option of installing recessed can lights. Recessed can lights can be safely installed within a soffit. These lights are designed to dissipate heat effectively and are suitable for enclosed spaces. Choose recessed can lights that are specifically rated for insulated ceilings and follow the manufacturer's installation instructions carefully. Make sure to use the correct type of insulation around the recessed cans to prevent overheating. As a last resort, consider opening a portion of the ceiling directly above the hutch to provide adequate ventilation for the existing puck lights. This will allow heat to escape from the soffit, reducing the risk of overheating. Ensure the opening is properly sized to provide sufficient ventilation and that it does not compromise the structural integrity of the ceiling. Seal any exposed cords with fire-rated caulk to prevent flames from spreading in the event of a fire. Fire-rated caulk is designed to resist high temperatures and prevent the spread of flames in the event of a fire. Apply the caulk to any areas where cords pass through walls or ceilings to create a fire-resistant barrier. Replace the existing insulation with fire-resistant insulation that meets building code requirements. Fire-resistant insulation is designed to slow the spread of flames and reduce the amount of smoke generated in the event of a fire. Install the fire-resistant insulation according to the manufacturer's instructions and ensure it is properly sealed to prevent air leaks. Calmly explain the situation to the owner and present the available options. Emphasize the importance of following code requirements for safety and insurance purposes. Clear communication is essential to resolving the issue amicably. Present the different legal options and their costs. Provide recommendations based on the specific circumstances and the owner's preferences. Be transparent about the potential risks and benefits of each option so the owner can make an informed decision. Be willing to compromise if possible. For example, you could agree to install heat-resistant puck lights and seal the cords with fire-rated caulk, while the owner opens a small portion of the ceiling for additional ventilation. Compromise can help find a solution that meets everyone's needs while ensuring safety and code compliance. Keep a record of all conversations and agreements made with the owner. This will help avoid any misunderstandings or disputes in the future. Document all communication in writing and obtain the owner's signature on any agreements reached. Remember to consult the National Electrical Code, or NEC, which provides specific guidelines for electrical installations, including lighting. Here are some key considerations based on the NEC. Firstly, Article 410.11 addresses the requirements for thermal protection of recessed lighting fixtures. It states that recessed lighting fixtures must be marked to indicate whether they are suitable for installation in insulated ceilings. If the fixture is marked as suitable for insulated ceilings, it must be installed in accordance with the manufacturer's instructions. If the fixture is not marked as suitable for insulated ceilings, it must be installed with a clearance of at least 3 inches from any insulation. Secondly, Article 400 covers the requirements for flexible cords and cables. It specifies the types of cords and cables that are permitted for use in different applications. In general, flexible cords and cables are not permitted to be concealed within walls, floors, or ceilings. However, there are some exceptions to this rule, such as for cord-connected luminaires that are specifically designed to be installed in concealed spaces. Thirdly, Article 300.22 addresses the requirements for wiring in ducts, plenums, and other spaces used for environmental air. It states that wiring installed in these spaces must be suitable for the environment and must be installed in a manner that does not create a fire hazard. In general, flexible cords and cables are not permitted to be installed in ducts, plenums, or other spaces used for environmental air. However, there are some exceptions to this rule, such as for wiring that is specifically designed for use in these spaces. When selecting and installing recessed lighting fixtures, there are several factors to consider. Firstly, the type of insulation. Different types of insulation have different thermal properties. It is important to select a recessed lighting fixture that is compatible with the type of insulation being used in the ceiling. Secondly, the clearance from insulation. If the recessed lighting fixture is not marked as suitable for insulated ceilings, it must be installed with a clearance of at least 3 inches from any insulation. Thirdly, the type of lamp. Different types of lamps generate different amounts of heat. It is important to select a lamp that is appropriate for the recessed lighting fixture and the environment in which it will be installed. In addition to the NEC, there may be local building codes that apply to the installation of recessed lighting fixtures. It is important to check with the local building department to ensure that the installation complies with all applicable codes. For example, consider using LED puck lights which generate less heat compared to halogen or incandescent lights, reducing the risk of overheating in enclosed spaces. Verify the puck lights are rated for enclosed spaces. Check the manufacturer's specifications and certifications to ensure the lights are designed for installation in confined areas. Hardwiring involves connecting the lights directly to the building's electrical system, eliminating the need for plug-in cords. Firstly, consult a qualified electrician to assess the feasibility of hardwiring the puck lights in the hutch. They can determine if the existing electrical circuit can handle the additional load and if any modifications are needed. Secondly, ensure the hardwired lights comply with electrical codes. The installation must adhere to local electrical codes and regulations, including proper wiring methods, grounding, and overcurrent protection. Thirdly, use appropriate wiring and connectors. Use electrical wiring and connectors that are rated for the voltage and amperage of the lights and that are suitable for concealed installations. Furthermore, consider using low-voltage lighting systems, which operate at a lower voltage and amperage, reducing the risk of electrical shock and fire hazards. Consider adding ventilation. If the hutch is tightly sealed, adding ventilation can help dissipate heat and prevent overheating. Firstly, install vents or openings in the hutch to allow for airflow. The vents should be strategically placed to promote air circulation and prevent heat buildup. Secondly, consider using a fan to circulate air within the hutch. A small fan can help move hot air away from the lights and prevent them from overheating. Thirdly, ensure the ventilation complies with building codes. The ventilation system must comply with local building codes and regulations, including requirements for fire safety and air quality. Evaluate the existing wiring insulation. The wiring insulation should be in good condition and rated for the temperature and voltage of the electrical system. Firstly, inspect the wiring insulation for damage or deterioration. Look for cracks, tears, or signs of overheating. Secondly, replace any damaged or deteriorated wiring insulation. Use electrical tape or heat shrink tubing to repair any damaged insulation and replace any sections of wiring that are severely deteriorated. Thirdly, use high-temperature wiring insulation. If the wiring is exposed to high temperatures, use wiring insulation that is rated for high-temperature applications. Check for proper overcurrent protection. The electrical circuit should have proper overcurrent protection, such as a circuit breaker or fuse to protect against overloads and short circuits. Firstly, verify the circuit breaker or fuse is properly sized for the electrical circuit. The circuit breaker or fuse should be rated for the amperage of the circuit and should be sized to protect the wiring from overheating. Secondly, test the circuit breaker or fuse to ensure it is functioning properly. Use a multimeter or circuit tester to verify that the circuit breaker or fuse trips when an overload or short circuit occurs. Thirdly, replace any faulty circuit breakers or fuses. Use a circuit breaker or fuse that is rated for the amperage of the circuit and that is suitable for the application. In addition, consider using GFCI protection for the circuit. Ground fault circuit interrupter, or GFCI, protection can help prevent electrical shock hazards. Firstly, install a GFCI outlet or circuit breaker on the electrical circuit. The GFCI outlet or circuit breaker should be installed in a location where it is easily accessible and can be tested regularly. Secondly, test the GFCI outlet or circuit breaker regularly to ensure it is functioning properly. Use a GFCI tester to verify that the GFCI outlet or circuit breaker trips when a ground fault occurs. Thirdly, replace any faulty GFCI outlets or circuit breakers. Use a GFCI outlet or circuit breaker that is rated for the amperage of the circuit and that is suitable for the application. Regular inspections are essential. Periodically inspect the lighting installation to ensure it is functioning properly and that there are no signs of overheating or damage. Firstly, schedule regular inspections of the lighting installation. The inspection should be performed by a qualified electrician who can identify and address any potential problems. Secondly, check for signs of overheating or damage. Look for discolored wiring, melted insulation, or charred components. Thirdly, address any problems promptly. Any problems that are identified during the inspection should be addressed promptly to prevent further damage or safety hazards. For instance, regarding the National Electrical Code, or NEC, Table 310.15, B16, formerly Table 310.16, it's essential for determining the ampacity of conductors based on insulation type and temperature rating. This table is critical for ensuring the wiring is appropriately sized for the load it will carry, preventing overheating and potential fire hazards. Using the correct ampacity is a fundamental safety measure in electrical installations. Furthermore, the specific type of insulation used on the wiring plays a crucial role in its ability to withstand heat. Common insulation types include THHN, THWN, and XHHW, each with different temperature ratings. It's important to select wiring with insulation that can handle the expected operating temperatures within the hutch, especially considering the enclosed space and potential heat generated by the lights. Therefore, ensuring the wiring insulation is appropriate for the environment is another key factor in preventing overheating. Installing the switch receptacle properly is paramount for safety and functionality. The switch should be rated for the voltage and amperage of the lighting circuit. If the hutch is in a damp or wet location, a weather-resistant receptacle should be used. Therefore, the selection and installation of the switch receptacle should follow safety guidelines. When the hutch goes from floor to ceiling, creating a concealed space for the wiring, the NEC has specific requirements for wiring methods. Article 300.4 addresses protection against physical damage, requiring wiring to be protected from nails, screws, or other objects that could penetrate the wiring. Article 334 covers non-metallic sheet cable, or often referred to as Romex, which is commonly used in residential wiring. Romex must be protected from physical damage and installed in accordance with the NEC guidelines. Therefore, compliance with NEC regulations for concealed wiring is critical. Addressing the owner's concerns and communicating effectively is paramount. Providing clear explanations of the code requirements and the potential safety hazards can help alleviate concerns. Offering multiple solutions such as heat-resistant lights, hardwiring options, and ventilation strategies can empower the owner to make informed decisions. A collaborative approach can lead to a mutually agreeable solution that prioritizes safety and code compliance. Communicating with the owner is critical. In these situations, remember that local building codes and regulations may vary, so it's important to consult with a qualified electrician or local building officials to ensure compliance with all applicable requirements. These professionals can provide guidance on the specific code requirements in the area and help ensure the installation is safe and code compliant. Therefore, consulting local codes and a qualified electrician is highly recommended. By taking these steps, the lighting installation can be legalized, ensuring the safety of the occupants and compliance with local electrical codes and regulations.